And don't forget to follow our channel. Question 3 will focus on sequence and series. You are most likely going to get a question around the geometric sequence as the last question on question 3. In this question 3.1, they've given us the sum of a series and they say is equals to m. Looking at this series, I can see that it is made up of a geometric sequence because I see this relationship here, which is the general term for a geometric sequence, for a geometric series. Right? I know this by experience because arithmetic sequence will be a linear equation, mx plus c, and a geometric series should be an exponential equation, right? Which is something that looks like that. Now they say in 3.1.1, write the below series in terms of n. They say we should write this in terms of n. So to do this, we must compare these two and see how we can rewrite this with m in it. Now, what I'm going to do is to rewrite this here to say we're doing question 3. We are on 3.1. We are given in 3.1 the sigma notation of 1 over 4, 3 to the power k, is equals to m. Under 3.1.1, they give us the sigma notation of 3 over 4, 3 to the power k minus 1. Then we're starting from k is equals to 5 to 15. Now, we can see similarities here. We can see similarities here. In order for me to change this to be in terms of m, I can isolate these two numbers here because I can see 1 over 4 here. So if I rewrite this as 1 over 4, and then I put a dot. Remember, a dot means multiplication times 3. This is still the same as that because if I multiply this and this, I get the 3 here, and here I have a 4. I'll remove the brackets and write a dot. Remember that the brackets in mathematics, they mean multiplication. So I'll write them as a dot, which also means multiplication. So that now I have 3 to the power k minus 1. Now this will be equal to, we're starting from k is equals to 5 to 15. This will be equals to the sigma notation. Now you must compare this to that as you go along. Do you see that we want to have that, meaning I can combine these two guys now using my laws of exponents. I can say 1 over 4, then I keep the base here, the 3, then I'll have the k minus 1 plus 1, because remember, we have an invisible 1 here. So I'm adding this k and the 1 because our law of exponents says you keep the base, you add the exponents. And of course, this starts from k is equals to 5 to a 15. Now, here we'll have the sigma notation is equals to 1 over 4. This should give me k to the power, no, not k, but 3, because we have a 3 here, 3 to the power k, right? And k is equals to 5 and a 15 here. But when you look at this, have a look at this, it's exactly the same as this, right? You can just put the brackets, you can remove the dot and put the brackets. They look exactly the same. It means this sum of terms is exactly equals to m. So in fact, this is m itself, right? this guy here is the same as M. We just proved him here. The question is worth 2 marks. So that means let's see how they're going to mark this one. So the 2 marks will come from, I think the final answer is the first thing that we can talk about, and also the fact that you used your rules of exponents to simplify, so they'll give you another mark for simplification. Now if we go to question 3.1.2, they say calculate the value of M. Calculate the value of M. Okay, let's see what are they asking us here. So this would be 3.1.2. We are looking for the value of M. What are we looking for really? Well, we're looking for the sum of this series, because we're saying the sum of this series is equal to M, right? And you know, this guy is exactly the same as this guy. So this would mean that what I'm looking for M is equals to. Now here I'll pull my calculator to find the terms in this series. Remember that those terms are given by this general formula. So this means I'll have a 1 over 4 multiplied by a 3 to the power. I'll start by 5 here, because we start at 5, very important. We don't start at 1, we don't start with T1. Our T1 starts at 5. So this would give me 243 over 4, right? I'm going to use this one to avoid working with this decimals, and then we'll say here we'll then put a 6 at the top. Here we'll put a 6 because after 5 we have a 6. Then this gives me 729 over 4. Then we'll add as well a 7. This gives me 2187 over 4. I only need 3 of these terms to begin with, right? So this goes into infinity, right? So looking for the sum of this. Now you would notice that here I suggested that this is a geometric sequence. So I'll check if I have a common difference, and if you do that, you would say 729 divide by 4, and then we're also dividing by, so I'm saying the second term divide by the first term, which is going to be 243 over 4, right? This gives me a 3. Guys, if you do the difference as well, the common ratio between this and this, if you divide this by that, you should get a 3, right? And of course we can see that our first term, our T1, which is a here, is given by this guy here, right, which is a 243 over 4. Now I can then come and say M is the same as Sn, because we are adding terms here, and we can see that this is a geometric sequence. It's a geometric sequence. So a geometric sequence is given by r to the power n minus 1 all over r minus 1. Now you can go to a formula sheet to get this formula. Now I'm going to substitute here the 243 over 4, 3 to the power 11. Right, this 11, where does it come from? Remember that we are starting at T5 to T15, right? T5 to 15. Remember, when you want to find the number of terms here, you will say n is equals to the upper bound, the upper limit, which is 15, minus the lower bound, which is 5, and you add 1, right? Please remember this here, because you can see we're not starting at 1 here. So this is how you find, you always say the top part minus the bottom part plus 1, right? and this will have here a 10 plus 1, which is 11, right? That's why here we have that 11 there. Then we're going to say minus 1 all over the 3 minus 1. Now we'll punch this in a calculator. Therefore, m is equals to, remember m is the sum here. So we'll punch this in a calculator so that we have the 243 over 4 bracket 3 to the power 11 minus 1 over 3 minus 1, and this gives me a 5,380,809.75, right? And this makes sense because if you look at this series, it's actually diverging. It's getting bigger and bigger as we add in terms. It's diverging. Our r, it's not between -1 and 1. So this series is diverging. So let's see how they're going to mark you for this one. It's 3 marks, right? So the first mark will come from your substitution, the fact that you did correct substitution, the fact that you got the right mark, and also the fact that you saw that this is a geometric series, right? Because someone could use an arithmetic sequence series equation, and the fact that also you got that r, that's where your 4 marks will come from. Now let's jump into 3.2. They say here at 3.2, the following is a geometric series. They give you this. So here we are on 3.2. In this 3.2, they say to us, we have 4 to the power x plus 16 to the power x plus 8x minus 1, and this continues into infinity. It's an infinite geometric series, right? Now they then ask us to calculate the value of the common ratio. So we want the value of r. So what is the value of r? So when they say value, you must give it in as a number, right? Because you can see here you have your x. Then now, because they've told us that it's a geometric series, it means it has a common ratio. That means if I take term 2, this term here, 16 to the power x, and I divide by the first term, this term here, it must be equal to, if I take the third term, this term here, 8 to the power x minus 1, and I divide by the second term, 16 to the power x. Divide this by that. The two ratios here must be the same. That's how we know that this is a geometric sequence. It has the common ratio, right? Now, to find r, we need to find the values of x here, and then we can be able to find r. So this, you can see it's an equation. So I'm going to solve this so that I can get the value of x. Now, to solve this, I'll say this is equal to, I'll write my 16 as a 2. I'll change it to a power of 2 to the power 4, because if you say 2 to the power 4, you get a 16, but I still have an x here. Then I'll divide this by 2 to the power 2. We know that 2 squared gives you 4, then I still have an x here. This side, I'll also do the same thing. I'll say 2 to the power 3. Then I have an x minus 1 there. And then here I'll have 2 to the power 4. We spoke about that. And here we will have an x outside there. If we, okay, here I shouldn't put an equal sign because I'm solving an equation, right? Unless if I say this implies, right? Now here at this stage, I'll write this as 2 to the power x for x, because remember, this will multiply that. This will also multiply that as well. So I'll have here a 2 to the power 2x, and this is equals to. So the same thing here, this will multiply this and multiply that as well. So the first part will be 2 to the power 3x, right? And the second one will be minus 3 there, because this times that is 3x, this times that is minus 3. And then here I'll have 2 to the power x, 2 to the power 4x, right? Now at this stage, I can then use my laws of exponents where I say I keep the base here and I subtract the exponents, right? I'll keep the base 2 and say 4x minus 2x is equals to, I do the same here, 2 to the power 3x minus 3 minus 4x. Now this will give me 2 to the power 4x minus 2x. That's like having 2x is equals to, we'll have 2 here. Now if you say 3x minus 4x, that will give you minus x, right? And then we have the 3 as it is there. Now remember, at this stage you can see I'm having two powers that are equal, right? We're saying they are equal, these powers, according to this equation. Now for these two powers to be equal, right, you can see that the bases are the same. Here I have a 2 and a 2, right? So for them to be equal, for this whole thing to be equal to this whole thing, it means this part and this part must be equal. You need to think about this really carefully. If I were to have the same number here, let's say we have a 3, we also have a 3 here, then these two things will be equal because it will be 2 to the power 3 and 2 to the power 3. So I'm going to argue that if these two are the same, therefore the 2x at the bottom should be equal, at the top, the exponent should be equals to the negative x negative 3. Right, and at this stage I can then solve for my x. Now I will take this guy this side, he's going to be a positive x, so that means I'll have here a 3x because 2x plus x is the 3x. Now I'll have a negative 3 here, so this means my x is equals to negative 1 because I'm going to divide by 3 here and a 3 here. This 3 and this 3 will fall out, then I'll have an x. 3 into 3, it goes once. Now this would mean that my r would be equals to, now I'm going to substitute this x here and here to get the value of r, because the question, remember, said we should get the value of r. So I'll have a 16 to the power negative 1 over 4 to the power negative 1. Then if you press this in a calculator, you'll have a 16 to the power negative 1 divide by 4 to the power negative 1. This gives me 1 over 4. So our common ratio is 1 over 4. Right? Let's see how this will get marked. So it was worth 4 marks, right? So the first mark will come from the fact that you know that the common ratio should be given by this, meaning setting up these two ratios to be the same. The third term divided by the second term being equals to the second term divided by the first term. Another mark will come from the fact that you did your simplification, the use of your laws of exponents, and manipulating until you get to the x, and then the other mark will come to the x, and the last answer will come from the fact that you calculated the answer, you give the value of r that they've asked you. So that's how the 4 marks should come. So be careful when you do these questions in terms of what is going to be marked, because if you don't write what's going to be marked, you simply lose that mark. Right, so we go to 3.2.2. They say explain whether this is a convergent or divergent series. So here we have 3. Let me go back to my blue pen. We have 3.2.2. Now in order to do this, remember, we know that a convergent series, we see it when our r lies between 1 and negative 1. We say that it is convergent. If it is divergent, you'll find that the r is greater than 1, right? So if you look at our r here, is between -1 and 1, right? So this series must be convergent. So we'll come here and argue to say, look, since -1 is less than 1 over 4 and is less than 1, all right, thus the series is convergent. The series is convergent, and then your 2 marks will come from writing this and writing your answer. Now, what do we mean when we say a series convergent? We mean that if we were to add these terms, as we're adding them, this series is getting closer and closer to a specific number. It's either getting small or it's getting to a number. Let's say it's going closer and closer to 3, right? Or going closer and closer to 10, right? It's not getting bigger. You know, sometimes when you add a series, a divergent series will be a series when you add these terms, it's actually getting bigger and bigger and bigger and bigger. It's giving you a large number as you add the terms, right? So a convergent one is going to a specific number. So here they say hence or otherwise. Remember in our previous question 2, we spoke about what hence and otherwise mean. Hence or otherwise calculate the sum to infinity. They want us to calculate the sum to infinity. To get the sum to infinity, this is 3.2.3. The first thing that you have to notice is that we have the first term, which is a, and in this case is 4 to the power x, right? It's 4 to the power x, but we know x is -1. So it means I'll put 4 to the power -1, which is 1 over 4. So the first term is 1 over 4. And we also know our r, the common ratio. We know that it is 1 over 4. I'm doing this, I'm finding the first term because I know that my formula of the sum to infinity is given by S infinity is equals to 1 minus r. So this means here I'll have 1 over 4 divided by 1 over 4, because the r is also 1 over 4. Now this is just a matter of putting it into a calculator, where we will say 1 over 4 divided by 1 minus 1 over 4. And this gives me 1 over 3. Right? So the sum to infinity actually tells us that if we sum the terms of this series, if we sum them, we continue summing them, they get closer and closer to 1 over 3. Right? That's why we're saying it is convergent. It is converging to 1 over 3. It's getting closer and closer to 1 over 3. So this question is worth 2 marks because there isn't much that you do here. They'll give you a mark for a substitution and 1 mark for the final answer. Right, then we're doing the last question now, question 3.3. Now in question 3.3, they say to us, the sum of the 5th and 11th terms of an arithmetic sequence is 14. Right, so what are they saying here? We are at 3.3. They say the sum of the 5th and the 11th term of an arithmetic sequence gives us 14. So when I add the 5th and 11th term, so I'm adding, I'm not subtracting, it actually gives me 14. Sum means we're adding, right? So because we know that this is an arithmetic sequence, it means I'm going to remember that this is the 5th term. So we know that the 5th term of an arithmetic sequence is defined by a plus 4d, right? This is this guy here. If you want the 5th term of an arithmetic sequence is given by a plus 4d. But we're adding this to the 11th term of this arithmetic sequence. Now the 11th term is given by a plus 10d, right? If you want the 11th term, you will say a plus 10d, and we're saying this is equals to 14. Now just to simplify this so that it is sitting All right, I will say the A plus the A would give me a 2A. I would say the 4D plus the 10D, that's a 14D, isn't it? That's the 14D is equals to 14. I'll call this equation 1. Now let's continue reading the question. They further then say the 32nd term of the geometric sequence is 1 over 2 and is the same as the common difference of the arithmetic sequence. Interesting stuff. So here we're saying if you take the 32nd term of a geometric series, it gives you 1 over 2, that term. But this 1 over 2 is the same as the D in the arithmetic sequence, right? The common difference, right? Automatically, this, when I look at it, it gives me equation 2 because I can see how this D, which is 1 over 2, will be useful here. I'm going to substitute that, which is what I'm going to do now. I'll say then now substitute equation 2 into equation 1 so that in equation 2 we have 2A plus 14. Now the D is 1 over 2, right? Is equals to 14. So here I still have 2A. Half of 14 is 7. So that is 7. And this is equals to a 14. I'll take the 7 to this side so that I have now 14 minus 7. So this side I'll have a 2A, 14 minus 7 again, it's half. It's like adding 7 and a 7, you get a 14. So if you subtract the 7 from a 14, you get a 7. So dividing both sides by 2, we get A to be 7 over 2. Right? Because we're dividing by 2 here, so that this cancels. Our question was saying calculate the first 3 terms of the arithmetic sequence, right? We're looking for the first 3 terms. Remember that A is the first term. Now to get the first 3 terms, we already have the first term as 2. Because we're looking for the first 3 terms of an arithmetic sequence, we know that to get an arithmetic sequence is a type of a sequence that we add the same number, a common number, to get the next term. So here we're adding 1 over 2 because we said the 1 over 2 is the same as the 32nd term of a geometric sequence is equals to 1 over 2 and is the same as the common difference. Now, if you take 7 over 2 and you add 1 over 2, that's a very simple fraction to work with, right? Because our LCMs are the same, they're both 2. You should get a 4 there. Then we continue adding the same number here because that's the nature of an arithmetic sequence. You add the same common number, right? The common difference. We call it difference because if you want this number, you say this minus that, then this number is a difference. But because now I'm building a sequence, I'm not doing it as a difference. I'm adding, it's a sum, right? To extend the sequence. If you say 4 plus 1 over 2, 4 plus a half, that should be a 9 over a 2. And this will continue like that because they wanted us to write the first 3 terms. And that's with 4 marks. Let's see how the 4 marks comes about. The first thing will come from the fact that you have set up your equations such that you understand what they mean when they say the sum of 2 terms equals to 14. The second one will come from the fact that you actually were able to construct this relationship that the 32nd is the same as the common difference, and substituting this into the equation, right? Being able to put it into that equation, and the last mark will be getting the value, no, not the value of A actually, but getting your sequence, being able to answer the question as they have requested you. That's the end of our question 3. If you are enjoying this type of content that I'm sharing with you, please like and comment.